Alright, so 11C is split up into two different parts. We're going to be simplifying trig expressions mostly today. A little bit, we'll be doing some of that tomorrow, not tomorrow, Monday as well. Today we're also going to be using some identities with our simplification. We're not going to have a lot of examples on it, but this also might include some expansion like distribution or binomial expansion, which sounds scary, but it's just foiling. You might have some foiling. So watch out for that, but we're going to focus mostly on the simplifying piece in the notes. Go ahead for your stat box if you haven't done that already. So we have some very important identities, both of which we've already had. So sine squared of x plus cosine squared of x equals 1. It's a very, very important identity, the Pythagorean identity. And then that the tangent of x equals sine of x over cosine of x, that's the trigonometric identity. Definitely have to remember those, but lucky for us, they're both in your IB formula packet. They're a little bit different in the packet because in the packet they use theta instead of x, and in the packet they have this switched around a little bit with the cosine first. But that's not really a big deal. It's just another variable like theta, right? Now, there are some other variables that you might see, and I just like to give kids a heads up because they kind of freak out when they see it. There's one that kind of looks like this. Okay, that's really bad. I'm really bad at drawing it. Like that? I don't know. I'm really bad at drawing it. Have you guys seen anything like that before? Because I'm terrible at drawing these. I feel like I need to look at a book. Maybe it's more like this. No. Well, there's one kind of like that that's called alpha, so it sort of looks like a crazy A with like some weird tails, kind of. See, I'm terrible at drawing them. It's okay. But you also might see this. That one's just beta. They're just Greek letters. So if you see some weird symbols instead of theta and x, like it's okay. And they'll be less weird than my drawings. So that's a plus. Now, going back to that Pythagorean identity, this top one, we can rearrange it, and it might look a little different. We have to be able to recognize the rearranged versions. So, like if I were to get sine by itself, I'd have to subtract cosine. So, sine squared of x would equal 1 minus cosine squared. And similarly, if I wanted to get cosine squared by itself, that would equal 1 minus sine squared. You have to be able to recognize all three versions of that. Like not just the original, but you have to be able to recognize these two. Now the rearranged versions are not in your packet. So, while you're doing your assignment, it's nice to have your notes out so you can take a look at that as well. So we are going to just do 3 short examples on some simplifying stuff. Any questions or concerns so far? So this one is probably so basic you're going to look at it and not be sure what to do. Sine theta plus sine theta. Well, how many sine thetas do we have? 2, and so that's it. See, that's what I meant. Like, some of them are going to be really, really basic, and you have to remember that you can combine, basically it's like combining like terms. We've got 2 of those. If I wrote x plus x on the board, you guys would have no problem with that. Are we okay? All right. So the next one, we are going to kick it up just a small notch. Negative 2 sine squared minus 2 cosine squared. So what you might have to do today is just like a little bit of factoring with like factoring figuring out any common factors or greatest common factor. We are going to get into much more factoring tomorrow, or how do you say tomorrow? Monday? So Monday we are going to do a lot of factoring, but today is going to be just kind of that basic factoring. So do you notice what number both of our terms have? A -2. So we can take out that -2. So when I take that out, I have left sine squared, and then that'll turn to positive cosine squared. We are going to go a little bit further than this. But if that step is hard for you, you can always just show that you're dividing out the -2. Because when you divide out the -2, it makes sense. And then that makes sense that would be positive. So if it helps you to do a little extra work, you can. Now, according to our identity, what does sine squared plus cosine squared equal? 1. So then my answer is just -2. So we've simplified that all the way. So that's using one of those identities. Okay. Any question before we get to the last example? Okay. So tangent of x, cosine of x, how can we simplify that? Well, what can we substitute in for tangent? Yeah, sine over cosine. So tangent would become sine of x over cosine of x. This still stays cosine of x. So now what? Yeah, if I put that cosine over 1, these guys are going to cancel out. So all I have left is sine of x. Okay. Any questions? Any concerns? All right. So then, the step x I think is a really good question. It's kind of difficult to answer. It's a good one though. Good to think about. How do you know that you've simplified enough? How do you know you're done? How do you know? Maybe it's one term. I don't know if that's always true, but that's a good, you try to get it down to one term. That makes sense. Okay, you've tried everything and nothing's going to work. I want to kind of expand on what Jerome said. And someone said it second hour, and I was like, that's a really good way to put it. When you know none of your identities you can work with anymore, you've tried everything, specifically looked at all those identities and the rearranged versions. Let me modify the question slightly. When you are doing your assignment over the weekend, how do you know you simplified enough? It does match the back of the book. Now, I know it's easy to write all those answers down, but part of how you learn is if you try to simplify these, check your answers. So if it doesn't match up, that's a learning experience for you to realize, okay, I need to simplify a little bit more. I need to look for something else I can maybe take out, I can maybe rearrange. So that checking in the back of the book helps you learn to recognize when you've simplified enough. So the 11C.1 assignments on the board. The one thing that's not really in the notes is that you might have some foiling, like I said earlier. So I put one in the success criteria here, expand, and you always simplify if possible. So this would be just like a foiling situation. So if you want to try that, you can, but you might see some of that stuff or some distribution stuff as well.